Hey, so today we're doing something you should probably never actually try. Falling into a black hole. Grab your popcorn. Or don't, because where we're going, popcorn won't survive either. Let's go. First off, what even is a black hole? Basically, it's a spot in space where gravity got so ridiculously strong that it crushed a dying star down into a single point. Imagine squeezing the entire Earth into the size of a marble. That's the kind of insane density we're talking about. Around that point is an invisible line called the event horizon. Think of it like the edge of a waterfall. Everything past that edge, light, matter, your stick figure body, gets pulled in, and nothing, not even light, can swim back upstream. Okay, so let's say you're an astronaut, and you're falling in feet first. Here's where things get weird. Gravity doesn't pull evenly. It pulls way harder on your feet, which are closer to the black hole, than on your head. Scientists actually call this spaghettification. Yes, that's the real term. You basically get stretched out like a piece of spaghetti being pulled from both ends. Not exactly the way you want to go out, but hey, at least it's memorable. Meanwhile, if your friend is watching you fall from a safe distance, say, orbiting nearby in a spaceship, something bizarre happens to their view of you. As you get closer to the event horizon, time appears to slow down more and more from their perspective. You'd look like you're moving in slow motion, freezing right at the edge, getting redder and dimmer, like a photo fading away. But from your perspective, you wouldn't notice anything weird happening to your own time at all. You'd just keep falling normally, right up until the stretching gets you. Freaky, right? Same event, two totally different experiences depending on where you're standing. That's relativity messing with your head. Now here's the part where physicists start arguing. What's actually at the center? Classical physics says there's a singularity, a point of infinite density where the normal laws of physics just stop working. It's like dividing by zero. The math breaks. Some scientists think quantum mechanics might replace that infinite point with something stranger we don't fully understand yet. Maybe not a true infinity, but something just as wild. Nobody's been able to peek inside and check for obvious reasons. And here's a fun bonus twist. Black holes aren't totally black forever. Physicist Stephen Hawking predicted they slowly leak radiation over insanely long timescales, now called Hawking radiation. And eventually, over trillions of years, they can evaporate completely. Oh, and one more mind-bender before we wrap up. Not all black holes are the same size. Some are stellar mass black holes, just a few times heavier than our sun. But then there are supermassive black holes, sitting at the center of galaxies, including our own Milky Way, that weigh millions or even billions of times more than the sun. And here's the kicker. The bigger the black hole, the gentler the stretching near the edge. Fall into a small one and you'd get spaghettified way before you even reach the event horizon. But fall into a truly gigantic, supermassive black hole? You could actually cross the event horizon in one piece, feeling almost nothing unusual, at least for a little while. Size matters, apparently, even in the most extreme places in the universe. Scientists figure this out using math, telescopes like the Event Horizon Telescope, which literally took the first ever photo of a black hole's shadow back in 2019, and simulations that model what light and matter do near these gravitational monsters. So even though nobody's coming back from inside to give us a report, we're not totally guessing here. So, to recap, you get stretched like spaghetti, your friends watching from afar see you frozen in time, and the center might be a mathematical impossibility that quantum physics hasn't fully cracked yet. Basically, black holes are one of the last true mysteries in the universe. We can predict a lot of what happens on the way in, but what's actually at the bottom? Still, one of science's biggest question marks. If you found this as mind-bending as I did, smash that like button, subscribe for more universe-breaking questions, and let me know in the comments Would you jump in if you could survive it? See you in the next one.